Creating virtual machines is the first step in building a comprehensive cloud infrastructure. On this foundation, the Servercore team creates managed PaaS products for our clients. PaaS products combine virtual infrastructure with special software on a virtual server. Think of PaaS as a set of tools that are partially set up to run or manage your apps. This lets you hand off some tasks to Servercore team so you can focus on the bigger business challenges. Let's return to the demo in the Servercore control panel, where Ivan will show you how to work with managed PostgreSQL databases and Kubernetes with various node group types. If you'd like to try working with cloud databases or Kubernetes cluster yourself, scan the QR code on the screen or follow the link in the description.
Virtual machines are a basic building block, not only for you when you launch something custom in a cloud, but also for cloud products like managed services. Now I will show you how managed services of Servercore, like managed databases and managed Kubernetes works, how they use those virtual machines to power their resources. Here again, I pre-created one database cluster to be able to later show you how it can be configured after launch. But now let's proceed to interface of cluster creation. What managed databases service basically is? It's a web service which helps you to launch one or multiple virtual machines with a specific software which knows how to work together in a cluster mode. In simple cases, you won't use clusterized mode, you will use single instance databases, but in production ready setups, we strongly recommend to use clusterized version of a database, and that's basically it. So it's just a very nicely made, highly optimized number of databases which work together. Let's see what Servercore offers us here. We can pick up a database engine. Basically, we have PostgreSQL, MySQL in two versions, semi-sync and sync. We have Redis and Kafka. I won't be able to cover all the details of all those databases, so let's just see what do we have for PostgreSQL. As you see, we have 5 different versions of PostgreSQL. This one, number 12, I guess 4 years old. Why do we offer it? Because we know that customers migrating to cloud sometimes face problems with transitioning from PostgreSQL or other databases they have used previously to something available in a cloud. The more the distance, the more troubles you have moving your database from something homegrown to cloud native solution. And the closer the version, the less problems you have. So it gives you time and provides with a smoother transition. Let's pick this version, PostgreSQL 12. What else shall we need to launch it? Of course, we should pick up the configuration like we've done with the virtual machine. You can take something from a predefined set. You see it more than enough variants available. Each flavor gives you quick insight of how much performance will you get from it. If you do know exactly which size of database you need, because you probably have an experience in that field, you can choose something custom. I will go with something like here for this demonstration. And the next option here is fault tolerance configuration options. As I mentioned at the beginning, the main feature of this service is that it's the probably easiest way to launch something which survives through disruptions. So it's really a problem to build PostgreSQL in a clusterized way. Someone who tried that knows it's not an easy task. Not while first launch, nor during upgrades or scaling. So adding replicas here with just a few clicks is a really nice feature for you to have. And for all production-ready loads, we highly recommend use at least one replica. If your software is it can use multiple replicas, for instance, for reading data, it may be some analytic systems. You will benefit from it, not having not only this resiliency. So I'll pick one replica here. I will choose subnet we have created previously, and I will not focus on the rest of the configuration options because they're too narrow for us for today. By the way, backups for your database are completely free of charge, no matter what volume size you use and how much data you write. It's a really great feature to have because it's not only gives you ability to recover with like minutes of precision, but saves you a decent amount of money. Let's create this cluster. We won't be able to wait until the full installation complete because it takes like 15 minutes, I guess, on average, depending on the volume size you pick of the database. So we'll leave it. We'll leave it setting up and see what we are able to do with the cluster I have pre-created. Well, again, like with virtual machine, one of the most used option here is scaling. You can easily switch your cluster from the configuration you picked at the start to some other configuration. And if your cluster, if you were using clusterized version of a database, this transition will pass unnoticed for your application and hence for your users. So after picking up the next configuration you need, just press save button, the cluster will switch to a resizing state. At the same page, you are able to copy connection strings for your database and tune some other options, which is also very important. Sorry, not this, but this is also a nice thing to have, like code snippets for connecting your applications in different languages. You can control users and databases through this API. You don't need to launch those SQL queries for that. And monitoring is available for each cluster you launch. Metrics are split into two sets. The first set is like infrastructure of your cluster. It's cluster service monitoring, CPU consumption, load average, and all that. And here, well, you can see the databases metrics more precise, tailored to the applications, and like longest query duration, for instance. You can export this data and use it in your own monitoring system because the data is available in Prometheus format. Let's send our cluster to resize to some of this configuration. Let's add one replica, press save button, and see what happens. Again, like I've said previously, depending on the sizes we pick here, the configuration type or configuration time differs. I believe this will be completed in 10 minutes. So, yeah. So our first cluster is in creating status and another one in resizing. So let's switch to another platform as a service product we have. It's managed Kubernetes. So in order to demonstrate its capabilities, I will switch to regions we have launched this service previously. When configuring a new cluster, you have to choose, like in managed databases or virtual machines, a version of a software of this cluster. You can see the number of options available here. Again, the purpose of this choice is for you to be able to transition to this solution easier if you already have something Kubernetes-based launched somewhere. We'll pick up, let's say Almaty. Cluster type allows you to choose either high availability mode or basic mode. Basic mode is really for testing purposes, which allows you to save some money. High availability is a must when you run production workloads. It allows you to go through some disruptions like node loss or node loss basically. It also allows you to later upgrade your cluster without server disruption. Let's pick up a new private subnet and proceed to a second stage. On the second stage, you tune node groups. Node groups is a configuration in your cluster which you will be able later use launching new nodes inside this group. So what you have to do is pick up the configuration. You have some kind of flexibility here. You see, you can use from 1 to 64 gigabytes of RAM, from 1 to 8 cores. You can pick the right volume type for each node. Let's see, we have, what if we have 10 gigabytes of RAM, universal volume of 10 gigabytes size. We press save, and we can choose amount of nodes to launch. There are some configuration Kubernetes specific like labels and tains. This will help you later control which applications to launch on which node. We'll dive deeper in it here. You can add, I guess, up to 10 or even more node groups here, having different configurations for each node. For instance, here for the second node, we can pick up local SSD and VMU volume. It's really useful if you plan to launch applications which demands very low disk response latency. Yeah. On the last step of cluster configuration, we have to choose whether we'll need our cluster to be able to auto repair, and would we like our cluster to be upgraded to a newer patch version if it appears in the cloud. By default, these two peaks are marked here, and it's advisable to do so. It will make your infrastructure stay in a greater shape no matter what. This auto upgrade will happen during a maintenance window, and you can pick the time for this window, starting time of this window. When we press create button, the cluster goes to create state. Normally it takes 15-20 minutes for the cluster to launch, depending on the size of the cluster, amount of the nodes. So in order not to wait too long, I will demonstrate what's possible to configure in a large cluster on something I have created before. Yeah, I have cluster in Tashkent. As you can see, this cluster contains only one node group. One node group, each node has such configuration. And there is only one node in this node group. What's possible to do here? We can resize this node group. So we can just add more nodes if our cluster is rigid and does not demand auto-scaling. What we also can do, we can turn on the auto-scaling, telling cluster which minimum amount of nodes it should have in this node group and which maximum it can scale up. let's press Save button. The cluster now should go to resize prepare state, still in this node group. Let's see what we also have here in these settings. We have a public address to connect our kubectl application, and here we can download config file for it. Yeah, we see here configuration options I set when I was creating the cluster. Here on the logs, in the log session, we see that like audit logs. I just put the node group into a resize state, and here I can see it. If for some reason a node in the cluster will be reinstalled or an update will be performed on top of your cluster, you will be able to see traces of those actions here. Servers that work as a Kubernetes nodes can be seen here in this list, but also you are able to find them here on the server sections. Here, this server R, first one, the second one. You might sometimes need it while debugging your application. Or for instance, if you lose access to your cluster with kubectl or in some other cases, you can work with those nodes as with servers, but the flexibility is limited. There is a message here and discover why is that. But at the same time, you can, for instance, snapshot a volume of your node group, connect it to another instance, and have a detailed understanding of what happens with it. That's all for PaaS services for today.